Very good morning, students. This is Dr. Rahim, which I'm going to teach you Unit 5, Analog VLSI Design. So, this is your fifth unit. You might be getting 15 to 20 marks from this. And I am going to divide into three different sections of this unit. You had amplifier, you had current meter, and you had op-amp and 6-bit flash IDC. So, first I'll start with the symbols, and we start with the amplifiers, and then we'll go for the first session. We'll go for the amplifier. We had two different types of amplifier: common source, common gate, and common drain. So common these amplifiers, out of these three you will get one. And we had current meter, source generated current meter, and cascode and Wilson current meter. This will be, will get it one question. Op amp design and this paradox, one question is going to come. So most probably minimum 15 to 20 marks are going to come from this unit. Let's start with the basic things. The topics which I'm going to cover to is nothing but NMOS, PMOS symbol, small signal of MOSFET, amplifier, common source, common drain, and common gate. So common drain amplifier is nothing but source follower, also known as, and also known as unity gain. All right. So we had common source amplifier with current meter, common drain amplifier with current meter, and common gate amplifier with the current meter. First, start with the symbols, and the symbols are most important for three-terminal device of NMOS and PMOS. And most of the students do mistake because they are unable to differentiate between the NMOS and PMOS. You had three terminals: gate, source, and drain. Source, drain can be interchangeable, but this is your gate, source, and drain. And the arrow mark towards the source, which is going nothing but this is your NMOS. Arrow marks towards the gate is nothing but this is your PMOS. So source, gate, and drain. You can also make the bubble. This is your PMOS. This is your NMOS. Source, gate, and drain. Source, drain can be interchangeable kind of so. And one more thing is, you had three terminal, but there will be a fourth terminal, that's a bulk. So that when you're trying to make an examination, you can use of a three terminal device. The fourth terminal, it is coming to the bulk to the body to the bulk to the source kind of stuff. So let us go for small signal model of a MOSFET. This is your NMOS, because gate, source, and drain, and the arrow marks towards the source. So that's the reason. And this pink with the voltage source applied is across your gate. This is a load resistance VDD is being applied, and this pink color is converted to the equivalent circuit. So this is the voltage across K2 source. You have transconductance parameter, current direction, and VGS, and this is your R node of your transistor. These three terminals: gate, drain, and source, which has been connected. So now this, when this circuit has been applied, one extra thing is added as load resistance. When load resistance is applied, out is a parallel to the R not parallel to the RL. So overall gain of this small signal MOSFET is nothing but output voltage by input voltage is given as minus GM into R. So that can be your gain of the small signal mode of MOSFET. Now go for the amplifiers. We had the different amplifiers: common source, common gate, and common drain. And common source amplifier, you had source is input voltage is applied from your gate, and source is grounded. Vout has been taken from a drain. This is your VCC has been applied load resistance RL. So same thing RL, but here this we have taken NMOS transistor in both all the cases of amplifier. Now in this common gate has been applied the DC supply of V bias, and source input voltage AC signal has given to the source of your uh, transistor. Common drain, we had it input applied across your gate, and now the output has been taken from your source, and this is acting as the resistor across to the ground. So this is the circuit of a common drain. This is also known as source follower, or else it is also known as unity gain, and one more name, it has a buffer. So it is to be connecting between two different circuit and making the matching between the output of the first stage to the input of the next stage of your amplifier circuits kind of stuff. So now let us go for common source amplifier with PMOS current meter. So current meter is nothing but the mirroring. When you look at when I look at it, the mirror, it will resembles to me. If someone is missing, that cannot be a mirror. So here the current is going to replicate to the another transistor kind of so. So common source amplifier, this is same circuit. We have taken NMOS Q1. Your current source is here. So now this circuit has been changed to the current meter. So here Q1 is your NMOS transistor, and this is again this is your PMOS transfer. Q2 is PMOS and Q3 is PMOS, and this is your current meter circuit. This part is your current meter circuit. So and this Q3 is diode connected. Whatever the current difference which is being applied at here is going to resemble across your Q2. All right. So this is mirroring it here. And now the input has been applied across your gate, and output has been taken from your drain from here. This is your common source amplifier with PMOS current meter. Now we had common gate amplifier with PMOS current meter. So this is the circuit diagram of your common gate amplifier, and here Q1 is your gate is applying voltage bias, and Uh, this is your Q2 transistor of your PMOS, and this current which is being diode connector of Q3, and the current is resembles across your Q2 kind of. So this is your common gate amplifier with your PMOS current mirror. Then we had common drain amplifier with NMOS current mirror. So in this case, previous case, upper module has been given as PMOS, but at bottom which using is nothing but NMOS current mirror. Either you can use of NMOS or PMOS. But in this case, common drain amplifier with I'm going to use of NMOS current mirror. This is your input is applied across. This is your NMOS transistor. Source resistance has been given. Output has been taken from your source or as VDD. So now here Q1 is your input is applied across your gate. Output is taken from your source. And now at bottom I had my NMOS transistor of current. This is part of your current Q2, and Q3 is whatever the current it has been connected, and the current which has been dissembled across your Q2. This is your common drain amplifier with NMOS current. So out of this amplifier you will get one, and you need to make an analysis and equivalent circuit, so that can be helpful for your examination. So that's all for today's section, and we'll come back for the next section with using of your current mirror. See you then. Thank you. Any questions you can ask. Thank you.